8.2, multiplying and GCF. We're going to be multiplying monomial to a binomial or a trinomial, and we're also going to be talking about the greatest common factor. All right, to multiply a monomial, which is one term, to a polynomial, we will use the distributive property and the exponent rules that we learned in the last chapter for multiplying. And remember, our exponent rules when we're multiplying, you multiply the coefficients or the big numbers, and you add the exponents or the little numbers. Okay, you're going to then combine like terms, which are terms that have exactly the same variable and exponent combinations, the same last names. So when you do this, remember there's not an equal sign in these problems, so these are called algebraic expressions. And that means that when you finish, your answer will be an expression, not a solution, okay? So we're going to multiply and distribute 2x times 3x, and we write it this way, or like I said before, you don't have to write out every single step, but you should, at least write down some of these things and show me some work. So 2x times 3x will give you 2 times 3 is 6. X1 plus x1 is x squared. All right, 2x times 1 is simply 2x. Anything times 1 is itself. So this is the simplified form, okay? This is just showing you how it's broken down. So your answer would be 6x squared plus 2x. All right, the next example is negative 1/2 x squared times the quantity of negative 4x squared plus 6x minus 8. You're going to distribute this negative 1/2 x squared all the way through to each term in the parentheses. So when you do that, it's negative 1/2 times a negative 4, which makes 2. And then x2 plus x2 is x4. Then you multiply negative 1/2 to 6, and you're going to get negative 3. X2 plus x1 makes x to the third power. And then negative 1/2 times negative 8 is going to be 4. And then x squared plus no more x's is just going to be x squared. So this is your simplified answer. Okay, 2x4 minus 3x3 plus 4x squared. This is in standard form in descending order. All right, the next example, sometimes you're going to have this distributing thing going on in the middle of a problem, okay? So you have to watch, look what's being distributed, and you have to do that first. Order of operations says you have to distribute first. So I'm looking at this. It says 2y squared minus 3y times 4x plus 5y. So I have to distribute this through first. So I'm going to write the 2y squared. I haven't done anything with that. And then I'm going to distribute the negative 3y. And it's negative 3 because it's the sign in front of it. All right, so it's a negative 3 times 4, which make a negative 12. And then x times y, or y times x, is xy. And then you have a negative 3 times 5, which is a negative 15. And then you have y1, and y1 make y squared. And then you look and see if you can combine like terms. In this problem right here, we had no terms that we could combine. All right, in this one up here, we had no terms we could combine, but in this particular case, we do. We have a y squared and another y squared, so these are the ones we need to put together. These right here. So when you do that, it's 2 minus 15, which make a negative 13y squared. And then you bring down your negative 12xy because it did not have anything to combine with. Now, when we're adding, we are not changing the exponents or anything. We're just simply adding or subtracting, so we're putting together like terms. You don't mess with the exponents. You just combine the ones that are the same. All right, so my final answer on this one is negative 13y squared minus 12xy. All right. Now, greatest common factor, or GCF, can be a number, a variable, or a combination of both a number and a variable that's in common with two or more terms. And we can use the prime factorization for this to find the GCF, or you may just recognize it just, looking at the numbers. Either way, if you need to do prime factorization, that's fine. But if you can recognize them, that's even better. It's quicker. But let's do a prime factorization just for practice. So I'm going to put the 42. I'm looking for the GCF between 42 and 60, so I'm going to have to do a prime factorization for each number. Right, 42, remember when we do prime factorization, we make a tree, and we divide out prime numbers. Well, this is even, so I know 2 goes into it, and 2 is the smallest prime number. So 42 divided by 2 leaves me with 21. That breaks down to 3 and 7. Okay, which is 2 times 3 times 7, which is right here. Okay, these are all prime. Okay, and then 60 breaks down to 2 and 30, which breaks down to 3 and 10, which breaks down to 2 and 5. All right, now all these are prime. Okay, and I wrote these over here, 2 times 2 times 3 times 5. Now, when you're doing a prime factorization, you're looking to see what is in common between both of those. So I have a pair of 2's, and I have a pair of 3's. So then you multiply the 2 times 3, which gives you 6. So in this problem, my GCF equals 6. Okay? Now, find the GCF between 18xp squared and 48x to the 4th power. Well, if you need to do a tree, you can do that. Okay, 18 and 48. And both of these are even. I'm going to start with a 2. 18 divided by 2 is 9. And that breaks down to a 3 and a 3. 48 is even, so I'll take that out as a 2, and that'll be 24. That breaks down to 2 and 12, which breaks down to 2 and 6, which also breaks down to 2 and 3. So I look for common factors. I have a 2 that's in common, and I have a 3 that's in common. So 2 times 3 is 6. All right, and then I'll look at my letters. I have, and if you need to spread them out, that's fine. One of them is an X, the other one is X4. I have one pair of X's in common. That's all I can take out. So the GCF between 18xp squared and 48x4 is 6x. You can only take out x to the 1 power, first power, because that's all that they both share. What will happen is if you see a letter in common, you'll take out the smallest degree, is what happens. Okay, so the GCF between those two is 6x. All right, so we will practice this in class. If you have any questions, come see me and get working.